Lesson, you'll be able to review some parts of the circle and find the length of an arc of a circle. Mensuration in mathematics is the process of measuring geometrical figures, especially applying them to the length, area, and volumes. Let's review the parts of the circle you learnt in your JHS mathematics syllabus. You were introduced to the concept of circles. A circle is a geometrical shape. Now, some geometrical circular shapes we see around us include the wheel of vehicles like bicycle wheels, steering wheels, just to mention a few. Now, a circle is the shape enclosed by a point which is always the same distance from the center. And the circle has many parts. In order to understand the work of a circle, you need to know the mathematical names of the various parts of the circle. We have the diameter, we have the radius, we have the chord, we have the circumference, we have the center, and we have the segment. And then we have what we call the sector. I'm sure you can see those parts in the circle. Now, the circumference is the term used to describe the distance around a circle. And the circumference of a circle is denoted by capital letter C and is given by the formula C is equal to 2 pi r, where r is the radius and pi is a constant given by approximately 22/7 or 3.142. Now, the arc. An arc is the term used to describe parts of the circumference of a circle, just a small portion of the circumference. The radius, which we normally write with small letter r, of the circle is the distance from the center to any point on the circumference. And the plural is radii. The diameter d is the line that divides the circle into two equal parts. The diameter of a circle is twice the radius. So we say d is equal to 2 times r. And then r is equal to d divided by 2. Again, there's something we call a chord. A chord is a line drawn from one point on the circumference to another point on the circumference. And the diameter is the longest chord you can have on a circle. It also starts from one point on the circumference to another point on the circumference. Again, a sector. A sector is the term used to describe a portion of the circle between two radii and an arc. For example, a semicircle is a sector of a circle because it is bounded by an arc and two radii. The diameter is actually 2 radii. Similarly, what we call a quadrant is a sector because it is bounded by an arc and 2 radii. Now, when the radii puts the circle into sectors, it produces what we call a minor sector and a major sector. One part is always bigger than the other. I'm sure you can see from our diagrams, the smaller part is always called the minor sector, and the bigger part is the major sector. Then we have the minor arc and the major arc as well. Now, a segment is the term used to describe the portion of a circle bounded by a chord and an arc. a chord is a straight line and an arc. Now, when a chord divides a circle into segments, it produces a minor segment and a major segment. And it also divides the circumference into a minor arc and a major arc, as in the diagram. Now we want to see how to find the length of an arc of a circle. As we said before, an arc of a circle is a portion of the circumference of the circle. Any 2 points on the circumference of the circle divides the circumference into 2 arcs. The larger arc is called the major arc, and the smaller one is called the minor arc. The length of an arc of a circle is simply the length of a portion of the circumference. And actually, the circumference itself can be considered an arc. So sometimes we say arc length. The angle AOB is called the angle subtended at the center of the circle. Now, if this angle is theta, then the arc AB is a fraction, which we can call theta over 360 of the circumference. And the circumference is 2 pi r. So we say that we have theta over 360 times the circumference of the circle. The length of the arc is found by decreasing the circumference by the ratio theta is to 360 degrees. Now, generally, for any length of arc of a circle subtended by an angle theta at the center, we say the length of the arc, which we represent with small letter s, divided by the circumference, which is c, is equal to theta over 360. That means if you divide the length of the arc by the whole length of the circle, it will give you the same answer as when you divide the angle by the whole angle in the circle, which is 360 degrees. Now, this is used to calculate the length of the arc. And so we say S over C is equal to theta over 360. But remember, C is the circumference, and this circumference is the same as 2 pi r. So we write this formula again, and we make it S divided by 2 pi r is equal to theta over 360. Now, if we make S the subject, we will get theta over 360 times 2 pi r. Now, that formula is very important because that is what we will be using to work our questions. So now it's time for us to solve some examples. Example 1. Find correct to 1 decimal place the circumference of the circle with radius 13 centimeters. And take pi to be equal to 3.142. Let's look at the solution. You need to remember that the circumference is the length of the full circle. And we said circumference, which is C, is equal to 2 times pi times r. So we put in our values. We get C to be equal to 2 times 3.142 times 13. Now that gives us 81.692 centimeters. We have to write our answer to 1 decimal place. So we get C to be equal to 81.7 centimeters. To find the length of an arc of a semicircle, we can easily find the length of the circumference and divide by 2. But we have to bear in mind that the angle subtended by a semicircle is 180 degrees. So we can still use the formula. So we have length of the arc of a semicircle divided by the length of the circumference of the whole circle times 2 pi r to be equal to 180 over 360 times 2 pi r. Now this gives us half times 2 pi r to be equal to pi r. That means you've done a bit of simplifying on the other side. And therefore, the length of an arc of a semicircle is equal to pi r. Now let's take another example. Example 2 says, find the length of an arc of a semicircle of radius 15 centimeters and take pi to be equal to 3.142. This time it says write your answer to 3 significant figures. So let's look at the solution. The length S of the arc of a semicircle is equal to pi r, which we saw earlier. Pi from the question is 3.142. The radius is 15. So when we multiply, we are getting 47.13 centimeters. But if you are writing your answer to 3 significant figures, it means you can have only 3 figures. So that gives us 47.1 centimeters. Again, we can find the length of the arc of a quadrant. You know, a quadrant is a quarter of the whole circle. So we do that by dividing the circumference of a whole circle by 4. But again, you must note that the angle in a quadrant is actually 90 degrees at the center. So again, we can say that the length of the arc of a quadrant divided by the length of the full circle times 2 pi r is equal to 90 degrees over 360 times 2 pi r. And that simplifies to give us 1 over 4 times 2 pi r. And therefore, the length of the arc of a quadrant is equal to pi r over 2. So we are saying that the formula for finding the arc of a circle is given by S equals theta over 360 times 2 pi r. Now, by transposing this formula, you can find the value of any of the letters in the formula. Now, let's take a few more examples. Example 3 says, find in terms of pi the length of the arc that subtends an angle of 60 degrees at the center of the circle of radius 12 centimeters. Now, in this question, we want to find S when theta is equal to 60 degrees and R is equal to 12 centimeters. So we put down our formula which says S is equal to theta over 360 times 2 times pi times R. Our angle is 60 degrees. So we have 60 over 360 times 2 times pi times R. And the R is 12 centimeters. So you cancel whatever things you can cancel from that expression, and your answer becomes 4 pi centimeters. Good. Again, example 4 says, the radius of a circle is 19 centimeters. An arc subtends an angle of 91 degrees at the center. Says calculate to 3 significant figures the length of the arc. This time it says take pi to be 22 over 7. So this question is asking us to find S when theta is 91 degrees and R is 19 centimeters. So again, put down your formula. S equals theta over 360 times 2 times pi times r. So, theta is 91 degrees from the question. R is 19 centimeters. So you substitute them. And you get 91 over 360 times 2 times pi. But your pi should be 22 over 7 times r, which is 19. Now, when you write this, you can cancel whatever things you want to cancel and write your answer in the simplest form. So that gives us 91 times 2 times 22 times 19, all divided by 360 times 7. And we get 30.1889 centimeters. Now, this answer should be written in the way the question asked. So our final answer, S, is equal to 30.2 centimeters. Now, example 5. It says a curve in the track of a railway line is a circular arc of length 400 meters and radius 1,200 meters. The question says, through what angle does the direction of the track turn? And the question says, take pi to be equal to 22 over 7. Now, in this question, we want to find theta, that is the angle. The question says, the length of the arc S is 400 meters and the radius is 1,200 meters. Now, pi is 22 over 7. So again, we put down our formula. S is equal to theta over 360 times 2 times pi times r. Your S has been given in the question and it is 400. So you substitute. We don't know theta. So we have 400 to be equal to theta divided by 360 times 2 times 22 over 7 times r. And the r in the question is 1,200. So you put in all your values. So cross multiplying, we get 400 times 7 times 360 is equal to 2,400 times 22 times theta. We want theta left alone. And so we will have 400 times 7 times 360 divided by 2,400 times 22. Now that gives us 1,008,000 divided by 52,800. And then we get our theta to be 19.0909 degrees. And to 3 significant figures, we get 19.1 degrees. I'm sure as you work the questions, you are beginning to put the formula in your memory. As you work with them, it just sticks. And you won't find it difficult to remember these formulae anymore. Let's look at another example. Example 6. It says the diameter of a circle is 16 centimeters. Find the angle which an arc of length 22 centimeters subtends at the center of the circle. And take pi to be 22 over 7. In this question, we want to find theta. We are given that S is equal to 22 centimeters and D is equal to 16 centimeters. So then we have theta over 360 is equal to 22 centimeters divided by 2 pi r. Now again, making theta the subject, we will get theta to be equal to 22 times 360 times 7, all divided by 16 times 22. That gives us theta to be equal to 2520 divided by 16. And that finally gives us 157.5 degrees. The next example, example 7, says an arc of length 15 centimeters subtends an angle of 45 degrees at the center of a circle. Find the radius of the circle and take pi to be equal to 22/7. Now, we want to find the radius. We are given that S is equal to 15 centimeters and theta is equal to 45 degrees. So again, we substitute these values in our formula and work. Now, since we know the length of the arc, we are going to put 15 for S. That will be equal to the angle 45 degrees divided by 360 degrees times 2 times pi times r. We don't know r. So we will gradually remove all the other numbers until we are left alone with r, and then we can get the value of r. So that gives us 15 times 360 times 7 is equal to 45 degrees times 2 times 22 times r. And again, that becomes 15 times 7 times 360 divided by 45 times 2 times 22. Cancel as many things as you can cancel and multiply the rest out. So we get r to be equal to 37,800 divided by 1,980. That gives us r to be equal to 19.0909 centimeters, or r to be equal to 19.1 centimeters to 1 decimal place. So in this lesson, we have learned that mensuration in mathematics is the process of measuring geometrical figures. And by that we mean measuring the length, the areas, and volumes. We also learned that the length of an arc of a circle is the length of a portion of the circumference. Again, the circumference itself can be considered an arc length. We also learned that the arc length is given by the formula S is equal to theta over 360 times 2 times pi times r. And we said when you take this formula, you can transpose and it will help you to find any of the variables in the formula. Well, this brings us to the end of the first lesson on mensuration. In the next lesson, we will learn about the perimeter of plane figures. Make a date and join us and learn some more. Until then, it's bye-bye.